Atomicity. The number of atoms present in a single molecule is termed as its atomicity. That means the number of atoms present in a molecule of an element is called as its atomicity, and it will be classified into different types, that is monoatomic, diatomic, triatomic and tetraatomic. Monoatomic molecules that contain one atom, for example argon, helium, that it contain only one atom. Second one, diatomic molecules that contain two atoms, for example oxygen, you see that oxygen O2, that means it contains two atoms. The third one, that is triatomic molecules that contain three atoms, for example ozone, that is O3, and carbon dioxide, it contains three, that means one has that carbon and two oxygen, it will be 3, so their atomicity is 3. And the next, tetraatomic, that means it contains 4 atoms, for example P4, that means it contains 4 atomicity. In the same has that polyatomic molecules also be there that contain more than 4 atoms, for example sulfur, that is S8, it contains more than 4, so it is classified as that polyatomicity. Next, valency. We all know that the chemical formula for the water is water. How many times have we wondered why it is written as H2O and not something else? What is the reason for this particular formula? The answer to the above question is valency. So what is valency? The total number of bonds that has the atoms has is called its valency. In other words, we can say that valency is the measure of the combining capacity of atoms or molecules. Therefore, it is the capacity of an atoms of a single element to react and combine with a particular number of atoms to another elements. For example, in the water molecules, oxygen combined with 2 hydrogen, so has the valency of oxygen is 2. A simple diagram of water molecules makes this plan. The hydrogen atom has each sharing one pair of electrons, so they have that valency of 1. Here the chart is given. For the hydrogen, the valency will be 1, for the helium 0, then lithium, that is 1. That means the combining capacity, that means it will combine with that one element or that compound. Next one, helium, there is no valency, so it has no combining capacity. Lithium, that means 1. That means based on this valency we can know that how that particular element will be combined to other elements. Writing chemical formula. A chemical formula is defined as the collection of chemical symbols that is used to show the elements present in any compounds and its proportion. Before we foray into that the area of writing a chemical formula, we must acquaint ourselves with the basics of chemical formula. Before moving that, you know that what are the rules that follow for writing that chemical formula. The first rule is that the valency or the charges on the ion must balance. And the second, when a compound consists of metal and non-metal, the name or the symbols of the metal is written first. For example, calcium oxide CaO, and the sodium chloride it is NaCl, iron sulfide FeS, copper oxide CuO, etc. Where oxygen, chlorine, sulfur are non-metal and are written on that right, whereas calcium, sodium, iron and the copper are metal and are written on that left side. And the third rule is that in compounds formed with polyatomic ions, the ion is enclosed in that bracket before writing the number to indicate the ratio. In case the number of polyatomic ion is 1, the bracket is not required. For example, NaOH. The simplest compounds which are made up of two different elements are called binary compound. While writing that chemical formula for compound, we write the constituent elements and their valency as shown in below. Then we must cross over the valency of combining elements. For example, here that carbon tetrachloride is given. The symbol for that carbon tetrachloride, that is CCl, means CCl. C, the valency will be 4 and Cl it will be 1. So we get CCl4. Second one, that magnesium chloride, the symbol for that magnesium Mg, and the Cl, that is for chlorine, and the valency for that magnesium is 2 plus and the chlorine it is 1 minus. After that interchange that the valency, it will be MgCl2. Next is chemical reaction. Chemical reaction are all around us, from the metabolism of food in our body to how the light we get from the sun is the result of chemical reaction. That means a chemical reaction is a process that occurs when two or more molecules interact to form a new product. A compound that interact to produce a new compounds are called reactant, where the newly formed compound are called product. Chemical reaction play an integral role in different industries, customs, and even in our daily life. They are continuously happening in our general surrounding. For example, the rusting of iron, pottery, then fermentation of wine. These all are that chemical reaction. In chemical reaction, a chemical change must occur which is generally observed with physical changes like precipitation, heat production, color changes, gas formation. There are different properties. Then a reaction which can take place between two atoms or ions or molecules, and they form a new bond, and no atoms is destroyed or created, but a new product is formed from the reactant. The rate of reaction depends on and is affected by the factors like pressure, temperature, and the concentration of the reactants. Chemical equation. What is a chemical equation? Chemical equations are symbolic representation of a chemical reaction in which the reactant and the product are expressed in terms of their respective chemical formula. They also make use of symbols to represent factors such as the direction of the reaction and the physical states of the reacting entities. Chemical reactions or the chemical equation were first formulated by the French chemist, that is Jean Bagun, in the year 1615. Chemical reaction can be represented on that paper with the help of some chemical equation. For example, here that example is given, that is CH4 react with oxygen, it will gives carbon dioxide and water. It can be observed in that example provided above that the reacting entities are written on the left hand side, whereas the products that are formed by the chemical reaction are written on that right hand side of that chemical equation. It can also be observed that there are coefficients assigned to each of the symbols of the corresponding reactants and the product, and these coefficients of the product entities is a chemical equation, and the exact value of the that means the number for that entities. That means it will be easily understood by that how these reactions will be written. What are the steps for balancing a chemical equation? Because we just go through that example of that above one, that is CH4 plus 2O2. It gives carbon dioxide. The means it will be that balance equation. And if the question will be given as unbalanced equation, how we balance that chemical equation? What are the steps for that? Here we take the same example, that is CH4 and that O2, but the chemical equation is not be balanced. First, identify the elements in the equation, that is carbon, hydrogen and oxygen. Then identify the net charge, no net charge, which makes this one easy. First, H is there in CH4 and H2O, so it's good starting element. You have 4H in CH4 yet only 2H in H2O. So you need to double the coefficient of that H2O to balance that equation. Then next, looking at carbon, you can see that CH4 and CO2 must have same coefficient. Then after that, finally determine the oxygen coefficient. You can see you need to double the oxygen coefficient in order to get 4 oxygen seen on that the product side of the reaction. Last, check your work. It is standard to drop a coefficient of 1. So the final balance equation would be written as CH4 plus 2O2 gives CO2 plus 2H2O. And here some questions are given. So students, here we complete that chapter. I hope you all understand the topic clearly and study well. Take care.